Hello there, and welcome to Infinity Beyond. I'm so glad you've chosen to spend part of your evening, or perhaps your early morning with us. Maybe you're in that mysterious time in between, floating in that serene space just before sleep takes hold. Wherever you are in the world, let me know in the comments. I love discovering where these quiet science journeys drift off to. And while you're there, if this video helps you feel at ease, or sparks a quiet sense of wonder, please consider subscribing. It helps us keep bringing these peaceful explorations into the vast unknown. Tonight, let's begin a cosmic journey, a soft unraveling of our origin story, not just as humans, but as stardust. At first glance, the idea may not seem that dramatic, but pause for a moment and consider this. Every atom in your body, carbon in your skin, oxygen in your breath, calcium in your bones, was born inside a star. You, me, all of us, we are literally made of star stuff. In the beginning, the universe was simple, just hydrogen and helium floating through space. Then gravity worked its magic. Clouds of gas collapsed in on themselves, growing denser and hotter, until one day, stars were born. Within the hearts of these stars, temperatures soared to millions of degrees. And under that intense heat and pressure, something extraordinary happened. Nuclear fusion. Hydrogen atoms slammed together, forming helium. Energy was released in the process, an immense amount, creating the very light that would later travel across space and time to warm our world. But more than that, these stellar furnaces were building complexity. As stars aged, they started fusing heavier and heavier elements. Helium turned into carbon, then oxygen, then magnesium, and on through the periodic table, until iron. At iron, the process changes. Fusion no longer releases energy. Instead, it consumes it. And so, the star prepares for a spectacular finale. Massive stars end their lives in dramatic supernova explosions. In those brief moments, they release enough energy to forge even heavier elements, gold, silver, uranium, and scatter them across space. That scattered debris becomes the raw material for planets, moons, oceans, and life itself. So when we say you're made of stars, it's not just poetic, it's literal. The iron in your blood, the calcium in your teeth, the potassium in your muscles, all once drifted through the vacuum of space, part of some ancient exploded star. The atoms that make you once belonged to something far older than Earth. Isn't that a humbling and comforting thought? Now imagine this. As you close your eyes tonight, the light from ancient stars still dances across your eyelids. Even now, photons born in stellar hearts are traveling millions of years just to reach you. Each starlight whisper a message from the past, reminding us of how interconnected we all are with the cosmos. It's easy to feel small in the face of such vastness. But what if, instead of feeling insignificant, we saw ourselves as cosmic miracles? Tiny reflections of the universe gaining the ability to contemplate itself. This isn't science fiction. It's science wrapped in wonder. And it's only the beginning. Let your mind wander now, gently, through this vast galactic nursery where stars are born and atoms are crafted with care. With every breath, you're participating in the story of the universe. Its chaos, its beauty, its elegance. Let the thought settle in you. You are not separate from the cosmos. You are the cosmos, in conscious form. And with that, drift gently into sleep, knowing that in the grand silence of space, your story has always been written in stardust. Welcome to another journey with Infinity Beyond. Tonight, we explore one of the most silent yet powerful forces in the universe. A force so gentle that it cradles us on Earth, yet so mighty it holds galaxies together. That force is gravity. As you settle in, take a deep breath. Feel your body gently pulled down by Earth's gravity. a silent embrace we often forget. Yet this same invisible tether extends far beyond us. It connects the planets, binds moons to their worlds, and orchestrates the movement of stars and galaxies on scales too vast to comprehend. Let's begin with the familiar. When you drop a pebble, it falls. When you jump, you land. These are simple moments, but they are echoes of a deeper cosmic law. Gravity doesn't just keep us grounded. It defines structure itself. Imagine the solar system. Planets orbiting the sun in predictable paths, each locked in a dance controlled by gravity. Mercury zips around quickly. Neptune glides slowly and distantly. The planets never drift off into the void, nor do they fall into the sun. Instead, they follow curved paths, perfect balances of inertia and gravitational pull. And yet, this is just the beginning. Gravity's true wonder reveals itself when we look at extreme scales, like black holes. These are places where gravity has won, where matter has been crushed to an infinitesimal point. A black hole's gravity is so intense that not even light can escape its pull. They are the ultimate expression of gravity's power. But here's something astonishing. Black holes aren't just cosmic monsters. They can be creators. At the centers of galaxies, including our own, lurk supermassive black holes. Millions, even billions of times more massive than our sun. And rather than tearing galaxies apart, they help hold them together. They anchor their swirling disks and influence the orbits of entire star systems. So the same force that lets an apple fall to the ground also crafts the spiral arms of galaxies. And it gets even more mysterious. Gravity is unique among the fundamental forces. It's incredibly weak compared to others, like electromagnetism or the strong nuclear force. And yet, because it only attracts, never repels, and because it acts across infinite distances, it dominates the universe on large scales. There's also something haunting about gravity. It shapes time itself. In Einstein's theory of general relativity, gravity isn't a force pulling objects like an invisible string. Instead, it's a curvature of space-time. Massive objects bend the very fabric of the universe, and smaller objects follow those curves. That's why light bends around stars, why GPS satellites need relativistic corrections, why time ticks slightly faster in orbit than it does on Earth. This means that wherever there is mass, there is not only structure, but also a gentle warping of time. As you lie there, imagine the world around you softly bending under your presence. Every mountain, every planet, every black hole is gently distorting the invisible fabric we call space-time. It's a quiet, cosmic lullaby. Now expand that thought outward. In galaxy clusters, gravity forms massive webs. Hundreds or thousands of galaxies bound together across tens of millions of light-years. Between them lies dark matter, adding to gravity's reach. And these cosmic filaments stretch across the universe like a neural network, connecting everything in an intricate design. Even the expansion of the universe is shaped by gravity's interplay with dark energy. Gravity wants to pull everything together. Dark energy pushes everything apart. This eternal dance between compression and expansion gives our universe its rhythm. One day, this balance might tip. The universe may expand forever, or perhaps it may reverse, collapsing in a big crunch. Or maybe something stranger awaits. But for now, gravity binds it all, quietly. Tonight, as you close your eyes, know this. You're resting not just on a bed or beneath a roof, but within the gentle pull of an ancient cosmic force. The same force that shaped the Earth, drew the moon into orbit, and stitched the stars into galaxies. Let that gravity carry you towards sleep. Feel its presence as a soft anchor, not just to the planet, but to the cosmos itself. You are held by the universe. Welcome again to Infinity Beyond, your gentle guide through the mysteries of the cosmos. Tonight, we turn our gaze from the stars above to something much closer, yet just as wondrous. The moon. Soft, silent, constant. It's watched over Earth for billions of years, pulling tides, guiding night travelers, and silently reflecting sunlight into our dreams. But how did it get there? Where did our moon come from? Let's explore one of the most extraordinary origin stories in the solar system. To understand the moon's birth, we must go back, far back, to the time when Earth was still young. The surface was molten. Volcanoes raged. Meteors crashed. It was a place of fire, chaos, and violence. And then, something unimaginable happened. A planetary body, the size of Mars, named Theia, collided with the early Earth. This was not a gentle nudge. It was a cosmic impact of staggering force. Debris from both Earth and Theia was launched into orbit, forming a glowing ring around our planet, an eerie halo of fire and dust. From this ring, over time, gravity worked its quiet magic once again. The debris began to clump. Pieces collided, fused, and grew. Eventually, they formed a single sphere, a new world in the sky. Our moon was born. At first, it was much closer to Earth than it is now, towering over the skies. Its gravity was stronger, pulling tides hundreds of feet high. These massive tides helped stir Earth's young oceans, potentially playing a role in the chemistry that sparked life. And while life slowly took root on Earth, the moon remained still, unchanged, yet ever-present, a silent witness to the unfolding story of life. Even today, the moon continues to shape Earth. Its gravitational pull slows our planet's rotation, gradually pushing itself farther away at a rate of about 3.8 centimeters per year. It's as if the moon is slowly waving goodbye, so slowly we'll never feel it. But over millions of years, the dance continues. Without the moon, Earth would be a very different place. Our days would be shorter. Our axis would wobble more dramatically, leading to wild climate swings. The steady rhythm of tides that nurtured early marine life would be lost. The moon doesn't just light our nights, it stabilizes our entire planet. And yet, it is so easy to overlook. How many times have you glanced at the moon without truly seeing it? Tonight, take a moment to reflect. That pale light you see is not just beauty, it's history. A world sculpted by ancient forces, a quiet companion molded from Earth's own body. And the moon is not lifeless in memory. Its surface still bears the scars of billions of years of impacts. Craters upon craters, frozen in time, telling a story of bombardments and stillness. A celestial archive of the solar system's wild youth. In recent years, scientists have confirmed traces of water on the moon. Thin, fragile, hidden in shadowed craters. And nations around the world now plan to return, perhaps one day to build moon bases or launch missions to Mars. But no matter how we explore it, the moon remains more than a destination. It is a mirror, a reminder, a keeper of Earth's oldest secrets. So tonight, as you prepare for rest, picture yourself standing in a lunar crater. Above you, Earth hangs in the black sky, blue, bright, spinning. From that distant surface, a collision long ago gave birth to the world beneath your feet. Let the quiet of the moon guide you to sleep. Let its stillness become your own. Because even in silence, the moon speaks volumes. Welcome back to Infinity Beyond, where each night we drift deeper into the wonders of the universe. Tonight, we'll follow one of the most mysterious and ancient travelers of our solar system. Comets. They blaze across the sky like cosmic fireworks. Brief, beautiful, and fleeting. But behind their shimmering tails lies a story billions of years in the making. So let's begin with ice. Long ago, in the cold outskirts of the early solar system, far beyond the planets we know, tiny worlds were forming. Not rocky like Earth or Mars, nor gaseous like Jupiter. These were icy bodies, frozen mixtures of water, methane, ammonia, and dust, untouched, preserved, suspended in the deep freeze of space. These are comets, and they are among the oldest, most unchanged objects in the solar system, time capsules from its earliest days. Most comets live in distant regions like the Kuiper Belt or the Oort cloud, far beyond Neptune. They orbit the Sun in huge elliptical paths, sometimes taking thousands or even millions of years to complete a single trip. But when they do venture inward, they awaken. As a comet approaches the Sun, it heats up. The ices begin to sublimate, turning directly from solid to gas. This creates a glowing coma, a thin atmosphere around the nucleus. Solar wind then blows this gas and dust into a spectacular tail which can stretch millions of kilometers across space. And yet the tail doesn't follow behind the comet like smoke from a train. It always points away from the Sun, pushed by solar radiation. Even if the comet is flying away from the Sun, its tail still streams ahead, defying what we might expect. It's a reminder, in space, things often behave beautifully and unexpectedly. Many cultures saw comets as omens, harbingers of change or chaos. But today, we see them differently, as messengers. Comets contain pristine material from the solar system's birth. By studying them, we unlock secrets about how planets formed, where Earth got its water, and even how life's building blocks may have arrived here. In 2014, the European Space Agency's Rosetta mission achieved the incredible. It sent a lander, Philae, to touch down on a comet named 67P. For the first time, humanity stood upon a frozen relic from 4.5 billion years ago. The lander's journey was not perfect. It bounced, then settled in shadow. But even so, it sent back valuable data. We learned that comets are more complex than we imagined. Layers of ice, organic compounds, caverns, dust storms, silence. The more we explore them, the more they reveal. Some comets have orbits that bring them back regularly, like Halley's Comet, which returns every 76 years. It last visited in 1986 and will return in 2061. Generations mark time by its passing. Poets write of its glow. Children watch in awe. It is both science and story. Other comets are visitors from the deep. They appear once and are never seen again, flung by gravitational nudges or born from interstellar space. One such traveler, Oumuamua, passed through our solar system in 2017. It wasn't a typical comet. It had no tail, no visible coma, and was shaped more like a pancake or a cigar. Scientists still debate what it was. A fragment of a shattered world? An interstellar iceberg? Some even asked, could it be artificial? We may never know, but the mystery itself is a gift. Because comets, in their quiet beauty, remind us that the universe is still full of questions. Tonight, as you prepare to sleep, imagine standing on the surface of a comet. Beneath you, dark rock and ancient ice. Around you, silence deeper than any on Earth. Above you, the sun, distant but growing brighter. You are moving, fast, faster than sound, faster than a bullet. Yet you feel nothing. The coma begins to form. The tail stretches behind you. You are now a beacon in the sky, a light traveling between worlds. And you carry a message, that even the smallest, coldest object can glow with purpose when touched by the light. Sleep well, traveler. The stars are still watching. Welcome back to Infinity Beyond, your peaceful escape into the wonders of the universe. Tonight, we descend into the fire beneath the silence, to uncover worlds where volcanoes sleep and sometimes awaken. When we think of volcanoes, we often imagine Earth, lava spilling down slopes, ash clouds reaching skyward, rumbling warnings deep within the ground. But volcanoes are not just an earthly phenomenon. They are written into the fabric of our entire solar system, on moons, on distant planets, and even in places where we thought fire could never survive. Let's begin with the largest volcano in the solar system, Olympus Mons. It rises from the surface of Mars like a sleeping titan, standing nearly 22 kilometers high, about 3 times taller than Mount Everest. It's a shield volcano so wide that if you stood at its base, its peak would stretch beyond the horizon. You wouldn't even realize you were climbing it. Olympus Mons formed slowly over millions of years. Mars lacks plate tectonics, so the lava always erupts in the same spot, building higher and higher. But here's the haunting truth. We don't know if it's extinct or merely dormant. It may sleep today, but one day it could breathe fire again. And Olympus Mons is not alone. Mars is dotted with ancient volcanic plains and extinct calderas, frozen in time. These features hint that the red planet was once alive with geothermal activity, possibly warm enough to host underground water or even life. But let's move farther out, to Jupiter's moon, Io. This is not a place of silence. Io is the most volcanically active body in the solar system. Imagine a world constantly reshaped by eruptions, geysers of molten sulfur, hundreds of kilometers high, rivers of lava weaving across a toxic, colorful landscape. Io's surface is in constant turmoil, scarred, cracked, alive. Why? Because it's being pulled, stretched, by the gravity of Jupiter and its neighboring moons. This tidal heating warms Io's interior, creating a world of fire in the cold outer solar system. Now contrast that with Europa, another of Jupiter's moons. Europa's surface is icy, still, quiet, but beneath that crust, a vast ocean, heated not by sunlight, but by the same gravitational friction. Scientists believe volcanoes may erupt on the seafloor, hydrothermal vents releasing minerals and heat. On Earth, such vents teem with life, even without sunlight. Could Europa be the same? Could volcanoes hidden under ice be keeping life alive? Then there's Enceladus, a moon of Saturn. At first glance, it's small and frozen, but something remarkable happens at its south pole. Jets of water and ice shoot into space through massive cracks called tiger stripes. These geysers are powered by heat from within. They contain organic molecules, salts, and possibly even ammonia. In 2000, NASA's Cassini spacecraft flew through these plumes and discovered what could be the ingredients for life. Again, volcanic activity, this time cryovolcanism, may be turning a frozen moon into a living ocean world. Yes, volcanoes can be icy too. On Pluto, we see mountains of frozen nitrogen and water ice that may have once erupted like glaciers flowing uphill. On Triton, Neptune's moon, geysers of nitrogen spew into space from under dark, icy plains. Even on Venus, our neighboring planet, recent radar scans suggest volcanic activity may still be occurring. The planet's surface is dotted with enormous lava plains and shield volcanoes. Some scientists believe Venus may not be so geologically dead after all. So many worlds, so many volcanoes, each different. Some fire, some ice, some ancient, some possibly still rumbling in the dark. Volcanoes are more than destruction. They're engines of change. They shape landscapes, release heat, and carry materials from deep within a world to its surface. They may have brought water to Earth. They may be warming Europa's oceans. They may even be kindling life in the most unexpected corners of the cosmos. And they remind us that even in places that seem still, something powerful may be stirring below. Tonight, as you rest, imagine standing on Io. Lava glows beneath your feet. Above, Jupiter looms in the sky, vast and stormy. Or perhaps you're drifting beneath Europa's icy crust, near a vent where warm minerals swirl through a black ocean. These are not fantasy. These are real places, waiting. Let the thought carry you deeper into sleep. that across our solar system, fire and ice dance in silence, shaping worlds unseen. And who knows what they're shaping still? Welcome back to Infinity Beyond, your quiet window into the cosmos. Tonight, let us listen, not with ears, but with wonder, to the language of stars. They don't speak as we do, but they do send messages. Across space, across time, across silence. They speak through light. Look up at the night sky, and you'll see tiny dots, stars, glittering and distant. But what you're really seeing is the past. Each twinkle is a message, traveling at the speed of light, taking years, even thousands or millions of years to reach you. When you look at the star Sirius, you're seeing it as it was 8.6 years ago. The light from Betelgeuse took 640 years to get here. Some of the stars in the Andromeda Galaxy, over 2 million years. You're not just looking across distance, you're looking through time. And light, it turns out, is full of information. To scientists, starlight is more than brightness. It's a story. A spectrum of colors reveals everything. What a star is made of, how hot it is, how old it is, even whether it's moving toward us or away. By breaking starlight into a rainbow of wavelengths, we see distinct lines, absorption lines, like barcodes. These lines tell us what elements the star contains. Hydrogen, helium, carbon, iron. From millions of miles away, we can learn the chemistry of a star without ever visiting it. This method, called spectroscopy, is like reading a star's fingerprint. And there's more. As stars move through space, their light shifts. If a star is coming toward us, its light compresses into shorter wavelengths, bluer. If it's moving away, the wavelengths stretch, redder. This is the Doppler effect, and it's how we discovered that our universe is expanding. Galaxies aren't just drifting, they're racing apart. The farther they are, the faster they flee. The redder their light becomes. And from this redshift, we learned something staggering. The universe had a beginning, a moment of sudden expansion. The Big Bang. All of that, decoded through light. Now consider something even more remarkable. Sometimes, a star's light doesn't arrive alone. Sometimes it flickers, dims, brightens. That's how we discover planets around distant stars, exoplanets. As a planet passes in front of its star, it blocks a tiny fraction of the light. By watching these faint dips, astronomers can detect worlds hundreds of light-years away. Some of these planets are Earth-sized. Some orbit in the habitable zone where water could exist. We even analyze the light passing through their atmospheres, looking for signs of oxygen, methane, or water vapor. In this way, light becomes our messenger, our telescope, our time machine. It is the oldest and purest form of cosmic communication. There's something poetic about this, that every star is constantly broadcasting, not in words, but in photons. That every twinkle in the night is a whisper from the past. A quiet, ancient voice saying, "I am here, I was born, I shine." Even supernovae, when stars die, send out blinding flashes of light, traveling across space for millions of years. Some of that light, reaching Earth, has been carved into cave walls by early humans, recorded by ancient astronomers in dusty scrolls, captured now by orbiting satellites. Starlight connects us all. It transcends language, time, and distance. And it illuminates not just the night sky, but our understanding of existence. So tonight, as you lie in bed, close your eyes and imagine light as a gentle river, flowing across galaxies, across eons, each photon a traveler carrying stories. Some of that light has traveled since before Earth existed, and now it gently touches your eyelids. You are not separate from the cosmos. You are bathed in its glow. Let it comfort you. Let it remind you that even in darkness, something is always reaching out, always speaking. In the silent vacuum of space, Stars have found a way to be heard, and now you are listening. Welcome again to Infinity Beyond, your sanctuary for quiet journeys across space. Tonight, we leave the familiar warmth of our sun and venture outward, far beyond the planets, past Pluto, into the deep, dim outskirts of our solar system. This is the realm of shadows and silence. The edge. But where exactly does the solar system end? Most of us imagine the solar system as the region that contains the 8 planets. Maybe you picture the asteroid belt between Mars and Jupiter, or the Kuiper belt beyond Neptune, home of Pluto and icy bodies. But the sun's influence extends much farther. The true boundary isn't defined by planets, but by wind. The sun constantly emits a stream of charged particles called the solar wind. This creates a vast bubble around the solar system called the heliosphere. Within this bubble, the sun's energy dominates. Beyond it, interstellar space begins. At some point, the solar wind slows and collides with the pressure of the interstellar medium, the gas and particles drifting between stars. This invisible border is known as the heliopause, and only 2 human-made objects have ever crossed it. Voyager 1 and Voyager 2. Launched in 1977, the Voyager probes were never expected to live this long. Yet decades later, they continue to drift outward, powered by small plutonium generators and guided by faint whispers from Earth. They carry golden records, messages from humanity encoded in sound and image, intended for any intelligent life that might one day find them. In 2012, Voyager 1 crossed the heliopause and officially entered interstellar space. In 2018, Voyager 2 followed. They are now over 20 billion kilometers from Earth, moving through the unknown. But even now, they still send data. They measure cosmic rays, magnetic fields, and particles from other stars. They are our ambassadors to the void, our eyes beyond the sun's light. And out there, in that distant cold, something mysterious lurks, the Oort cloud. We've never seen it directly, but based on the behavior of long-period comets, scientists believe this vast sphere of icy debris surrounds the solar system like a shell, extending perhaps up to 100,000 AU, astronomical units, from the Sun. The Oort cloud is not a ring like the Kuiper belt, it's 3-dimensional, a distant graveyard of frozen relics from the solar system's formation. Every so often, a passing star or gravitational nudge sends one of these icy objects tumbling inward. They become comets, arcing through the inner solar system, lighting up our skies for a brief, brilliant moment before fading once more into the dark. These icy wanderers remind us of just how vast, how ancient, and how fragile our solar home really is. Out here, sunlight is weak, a whisper. The warmth we take for granted on Earth becomes a memory. Temperatures drop to near absolute zero. Time feels different, and yet, even in this frozen frontier, there is a quiet elegance. The edge of the solar system is not an end, but a threshold. Beyond it lies the Milky Way. Billions of stars, countless worlds, an ocean of possibility. It's here, in the silence, that we begin to understand the scale of existence. That Earth is not the center. That even our sun is just one of many lights. And that the boundary we thought marked the end is only the beginning. Tonight, as you drift to sleep, imagine yourself aboard Voyager 1. You float in a silent craft far beyond Pluto. Behind you, the sun is a pale dot, no brighter than any other star. Ahead lies infinite dark. There is no noise, no gravity, only movement, forward. And in that stillness, you carry a record, a message of who we are, of where we came from, of what we hope to be. You are not lost, you are exploring, and you are not alone. Welcome back to Infinity Beyond, where we journey through space not with rockets, but with thought, wonder, and stillness. Tonight, we leave behind space itself and drift into something even more elusive. Time, we live by it, we chase it, we measure it in seconds, in hours, in years. But what is time really? And how does the universe keep track of it? Let's begin by pausing. Feel this moment. It's already gone. Another has taken its place. Time flows forward, always forward. But in the language of physics, time is not separate from space. It's part of a larger fabric, space-time. Introduced by Albert Einstein's theory of general relativity, space-time isn't a backdrop. It's a thing. It bends, stretches, and warps in response to mass and energy. Wherever there's gravity, there's distortion of time. This means that time doesn't flow the same everywhere. On Earth, clocks on airplanes tick slightly faster than those on the ground. In orbit, GPS satellites account for the difference. Near a black hole, time slows dramatically. And in the early universe, time itself was compact, dense, fast, chaotic. So we ask again, what is time? To many scientists, it's change, the measure of one event relative to another. Without change, time would have no meaning. But there's more. When we look at distant galaxies, we're not just seeing space, we're seeing the past. A galaxy 10 million light-years away, we see it as it was 10 million years ago. Telescopes are time machines, capturing the universe not as it is, but as it was. Even light from our own sun takes 8 minutes to reach us. When you watch a sunset, you're seeing a memory. And it gets stranger. Some theories suggest that time may not be fundamental, that it's emergent, a product of something deeper, like temperature or entropy. Entropy, the tendency of systems to move from order to disorder, is what gives time its arrow. It explains why we remember the past, but not the future, why broken cups don't reassemble, why we age. Entropy increases and time moves forward. But here's a thought that might keep you up, or gently guide you to sleep. At the deepest level, the laws of physics don't care about direction. Equations work the same forward or backward. So why does time feel like it only flows one way? Some believe it's perspective, that we, as conscious observers, are simply riding a current. Others speculate that time may loop, or branch, or be an illusion altogether. And then, there's the concept of cosmic time. This is time measured from the perspective of the universe itself. It began at the Big Bang, around 13.8 billion years ago. Cosmic time isn't concerned with local gravity or black holes. It's the clock ticking since the birth of everything. Through cosmic time, we chart the great epochs. The birth of light, the formation of galaxies, the first stars, the rise of life, and maybe one day, its end. But even endings aren't simple. Will time end with the universe? Will it stretch forever in a big freeze or collapse in a big crunch? Or will dark energy tear it all apart in a big rip? We don't know, and perhaps that's okay, because the beauty of time isn't just in understanding it, it's in feeling it, living it. Tonight, as you rest, feel time slow. Breathe in, breathe out. Let each breath be a moment. You are part of the universe's clockwork. You are stardust, animated by time, carried by cosmic currents. Close your eyes and imagine drifting across the stars. Not at the speed of light, but at the speed of now. Past galaxies, past nebulae, past moments. You are timeless, and time is yours. Welcome back to Infinity Beyond, where we float through the deepest questions of the cosmos, one peaceful thought at a time. Tonight, we don't just travel across the universe. We wonder if there might be more than one. We ask the question, what if our universe isn't the only one? What if reality is far stranger, more layered, and more infinite than we ever imagined? Let's explore the haunting and beautiful idea of the multiverse. We begin with something familiar, our universe. It's vast beyond comprehension. Roughly 13.8 billion years old, filled with over 2 trillion galaxies. It contains space, time, matter, energy, light, dark matter, dark energy, and you. For all our searching, we found no edge, no center, and no duplicate. But what if this universe is just one bubble in a vast cosmic foam? This is the multiverse theory, and it comes in many forms. One idea arises from cosmic inflation. Right after the Big Bang, the universe expanded rapidly, faster than light. Some theories suggest this expansion didn't happen just once, but repeatedly, in different places. Each bubble universe inflated on its own, with its own laws of physics, particles, and dimensions. Imagine it, a universe where gravity is stronger, another where stars burn cold, a reality with no atoms, no time, or one where stars never formed. We wouldn't just be in a vast universe, we'd be in a sea of universes. Most alien, some may be eerily similar. And that leads us to another idea, the many worlds interpretation of quantum mechanics. You've probably heard of Schrödinger's cat, the paradox where a cat in a sealed box is both alive and dead until you observe it. In the many worlds view, both outcomes actually happen in separate branching realities. Every choice, every quantum event splits reality. In one world, you turn left. In another, you turn right. In one, you stay. In another, you go. According to this theory, there are infinite versions of you, each living out different paths. Fascinating, humbling, and impossible to confirm, at least for now. Another version of the multiverse comes from string theory, a mathematical framework that tries to unify gravity with quantum mechanics. It predicts the existence of many possible solutions to the equations describing our universe, each representing a different universe with different dimensions or physical constants. These aren't just philosophical musings, they emerge naturally from our best attempts to understand reality. But here's the twist. We can't see these other universes. They don't interact with ours, at least not in any measurable way. They're beyond our horizon, beyond our tools, perhaps forever unreachable. So why do scientists still consider them? Because the math suggests it. Because the cosmos may be too perfect to be the only one. Because some fine-tuned properties, like the exact strength of gravity or the mass of the electron, seem almost improbably suited for life. In a multiverse, this becomes less mysterious. We're simply in the one where life could happen. The others are silent. It's called the anthropic principle. The idea that we observe a universe compatible with life because we're here to observe it. Still, the multiverse remains one of the most debated ideas in modern science. Some call it a necessary extension of inflation and quantum theory. Others call it untestable, unverifiable, a mathematical ghost story. But regardless of where you stand, the concept touches something deep in us. It invites awe, it asks us to imagine more. So tonight, as you prepare for sleep, imagine this. You are floating in a bubble. Around you, stars swirl, galaxies dance, and light stretches across time. But beyond the bubble's wall, there are others. You can't see them, you can't touch them, but you feel them. They shimmer with other possibilities. You drift slowly between these realities, gently brushing the edge of infinite maybes. In one world, you are listening to this for the first time. In another, you are watching stars rise from oceans. In another, still, your universe has never known light. But here, in this one, you breathe, you wonder, you dream, and that is enough. Welcome back to Infinity Beyond, your quiet escape into the mysteries of the cosmos. Tonight, we drift toward one of the most enigmatic, haunting, and beautiful phenomena in the universe, the black hole. It has no surface, No edge you can touch, no way to see what lies inside. And yet, it may be the key to understanding time, space, and perhaps even what lies beyond them. Let's begin with the basics. A black hole forms when a massive star dies. After burning its fuel, the star collapses under its own gravity. If the core is heavy enough, no known force can stop it. The collapse continues until the matter is crushed into an infinitely small point, a singularity. Surrounding it is the event horizon, the point of no return. Cross it, and even light cannot escape. That's why black holes are invisible. But we know they exist because of how they affect the world around them. We see stars orbiting nothing, gas spiraling inward, heating up, glowing. We even captured an image of one, a bright ring of light surrounding darkness, using a global network of telescopes. That was M87, a supermassive black hole 55 million light-years away, larger than our entire solar system. And at the center of our own Milky Way, there's another, Sagittarius A. Quiet, dormant. But there, black holes come in many sizes. Some are a few times the mass of the Sun. Others, millions or billions of times more massive. And they may not just destroy. They may shape. Supermassive black holes anchor galaxies. Their gravity holds star systems in place. Their feeding cycles regulate star formation. They are cosmic engines, silent but essential. And yet, the mystery deepens. Time behaves strangely near a black hole. The closer you get, the slower time moves, until it nearly stops at the event horizon. To a distant observer, someone falling in would appear frozen in time, forever just outside the edge. But to the one falling, they'd pass through without noticing, drifting into darkness, toward the singularity. No one knows what happens inside. Our physics breaks down. General relativity predicts one thing. Quantum mechanics suggests another. And reconciling them, that's one of the greatest unsolved challenges in science. Some theorists suggest black holes may be gateways, portals to other parts of the universe, or even to other universes entirely. Wormholes, bridges through space-time. Concepts once limited to science fiction now emerge from equations. Others think black holes may not destroy information at all. Instead, they might store it, encoded in the quantum ripples on their surface. This leads to the black hole information paradox, a puzzle debated for decades. Even stranger, black holes evaporate. Yes, over immense timescales, black holes emit radiation, called Hawking radiation, predicted by Stephen Hawking in the 1970s. They lose mass, they shrink, they die, but slowly, so slowly. A black hole the size of the Sun would take longer than the age of the universe to evaporate. And yet it will. In the far future, when all stars have gone dark, black holes will be the last to remain, slowly fading into silence. They are the end, and possibly since a beginning. Tonight, as you prepare to sleep, imagine standing at the edge of a black hole. You gaze into the void, and it gazes back. Around you, space is warped, light bends, and time slows. You feel the tug, but you are safe. Just beyond the horizon, infinity waits. Let it remind you, even the darkest places hold wonder. Even the most terrifying ideas carry beauty. Black holes are not to be feared. They are to be understood. They teach us humility. They stretch our minds, and they whisper of truths not yet grasped. So sleep now, traveler of thought. The universe still has secrets, and you're listening. Welcome back to Infinity Beyond, where we wander the universe in silence, and sometimes we listen for what isn't there. Tonight's question is simple, yet beautiful. Can space make a sound? At first glance, the answer seems obvious. Space is a vacuum. No air, no molecules, And sound, at least the kind we hear with our ears, needs a medium to travel through. On Earth, sound moves through air, through water, even through the ground. But in space, there's nothing. So is it truly silent? Let's explore. Technically, in the vacuum of space, you wouldn't hear anything. Not with your ears. No swooshing of rockets. No explosions like in science fiction. If you were floating in space, even right next to a supernova, your eardrums would hear nothing. But here's the twist. Space isn't completely empty. In many places, especially inside galaxies or near stars and planets, there are clouds of gas and plasma, ionized particles that can carry pressure waves. These aren't sound in the traditional sense, but they are vibrations. And where there are vibrations, there can be interpretation. NASA and other space agencies have recorded these plasma waves using special instruments on spacecraft. Then they convert them into audio frequencies our ears can perceive, a process known as sonification. The results? Haunting, beautiful, otherworldly. For example, the Juno spacecraft recorded the sounds of Jupiter's magnetosphere. It's not music, but a chorus of whistling, crackling, and deep pulses. Saturn's rings, they produce eerie rhythms. The Earth itself, through instruments on the Van Allen probes, emits a chorus of rising and falling tones, almost like bird songs, created by charged particles interacting with Earth's magnetic field. Astronomers have also taken data from telescopes, images, brightness, X-rays, and turned that into sound. Stars become melodies. Galaxies become sweeping orchestras. Black holes become deep, trembling hums. One famous example comes from the Perseus galaxy cluster. Scientists discovered that waves rippling through hot gas in the cluster created vibrations, sound waves, with a pitch 57 octaves below middle C. It's a tone far below human hearing, but it is a sound, a real vibration traveling through space for over 250 million light-years. The universe is singing. We just need the right ears. So what is it about sound that draws us in? Perhaps it's that sound is emotion. It's the invisible thread that connects a mother to her child, a violin to a heart, a story to its listener. By listening to the universe, not just seeing it, we experience it differently. We feel it. It becomes poetry. It becomes presence. Even silence, in this way, becomes profound. Because space is not silent out of emptiness, but out of vastness. The distances between stars are too great, the particles too sparse. But in that quiet, there is meaning. Let's also imagine other ears, alien ears, creatures born in different atmospheres under different suns. What would they hear? Would their stars hum? Would their planets resonate with deep, slow echoes? Would their understanding of sound be completely alien? And maybe they too have tried to listen outward, to hear us. This is part of the work done by SETI, the search for extraterrestrial intelligence. Radio telescopes scan the sky, listening for narrowband signals, artificial beacons that might indicate intelligent life. So far, we've found no confirmed messages, but the listening continues, because even in the silence, there's hope. Tonight, as you prepare to sleep, let your mind drift through this quiet universe. Imagine you're aboard a deep space probe, drifting slowly between galaxies. All around you, stars glowing in silence, but your sensors begin to hum. The faint song of plasma, the low growl of cosmic radiation, the shimmering notes of magnetic fields dancing across space. It's not silence. It's a deeper kind of music. You float, listening, and in that moment, you understand. The universe doesn't speak with words, or even with sound, but with patterns, with waves, with resonance. And we, the listeners, are part of that great cosmic symphony. So sleep now and let the universe sing to you. Welcome back to Infinity Beyond. your gateway to gentle cosmic wonder. Tonight, let's take a journey not through stars or galaxies, but through skies. Not Earth's skies, but those of alien worlds. Have you ever wondered what a sunset would look like on Mars? Or how the sky would appear if you stood on a moon of Jupiter? Would the light be red, blue, green? Would there be two suns or none? Let's leave Earth behind for a little while and explore the alien atmospheres of the cosmos through the lens of light, color, and imagination. Mars, the blue sunset. We begin with our closest planetary neighbor, Mars. Known as the red planet, Mars has a thin atmosphere filled with dust. During the day, the sky appears butterscotch or salmon-colored, tinted by iron-rich particles suspended in the air. But at sunset, something magical happens. As the sun sinks, the Martian sky turns blue. That's right, sunsets on Mars are the opposite of Earth's. While Earth's sky scatters short blue wavelengths more during the day, making the sky blue, Mars's dusty atmosphere scatters longer red wavelengths and lets blue light through more effectively near the horizon. The result? A cold, dusty planet where sunsets glow in gentle blues and indigos, quiet, solemn, and beautiful. Now let's float farther. Venus, the eternal twilight. On Venus, the sky never clears. Thick clouds of sulfuric acid choke the atmosphere, and the surface pressure is 90 times that of Earth. Sunlight struggles to break through, and when it does, it's distorted, muted, and orange-hued. If you stood on Venus, protected by some miraculous suit, you wouldn't see the sun at all, just a dim glow like twilight on a stormy day, all day. There is no bright noon, no clear night, only a constant, toxic twilight. And yet, in that muted orange, there is a strange calm. Titan? Orange dreams. Next, let's visit Titan, Saturn's largest moon. Titan has a thick atmosphere, denser than Earth's, and it's filled with methane haze. The sky is orange, the sunlight is dim. During the day, everything is bathed in a soft amber glow, and as the sun dips below Titan's horizon, the orange deepens, softens, and blends with hues of gray. No stars would twinkle overhead, only a glowing haze. And yet, in that alien sky, there's a quiet beauty, a suggestion of rain, not of water, but of liquid methane, falling gently in silence. A world that feels like a dream, frozen in orange light. Exoplanets, two suns and purple skies. Now imagine a planet orbiting two stars, like Kepler 16b. Here there are two sunsets. One star disappears, then the other. The sky glows in overlapping halos. Shadows stretch and twist in strange directions. And the colors? That depends entirely on the star's temperatures. A red dwarf paired with a yellow sun would create a sky tinted with purples, oranges, and copper. Imagine watching two stars set behind a mountain range made of ice, the sky darkening not once, but twice. Or consider a world like HD 119733b, a hot Jupiter with fierce winds and a deep blue hue. Its atmosphere scatters light like Earth's, but at higher energy. From space, it looks like a sapphire. On the surface, if you could survive it, sunsets might flash electric blue, quickly fading into violent storms of glass shard rain, whipping sideways at thousands of kilometers per hour. A beautiful nightmare. The moon. No sky, only stars. And what about our own moon? It has no atmosphere, no scattering, no haze. The sun rises and sets in total silence against a pitch-black sky. Even at noon, stars remain visible. Shadows are razor-sharp. The contrast is harsh. A sunset on the moon isn't a fade of color. It's a slow loss of light. The sun slides behind lunar hills, and darkness falls instantly. There's no atmosphere to carry light beyond the horizon. And yet, it's perhaps the most honest sky in the solar system. Nothing but sunlight, shadow, and eternity. Skies of the imagination. Finally, let's imagine skies we haven't yet seen. What would a sky look like on a world orbiting a dying star, casting red light across icy cliffs? Or under the glow of a pulsar, where flashes of radiation pierce the dark like a cosmic strobe? Or on a planet circling a black hole, where light is bent and twisted into surreal loops with sunsets that never end? Each sky tells a story. Each world writes its own light. As you sleep tonight, imagine yourself on a quiet ridge overlooking an alien valley. The air tastes different. The colors shimmer in ways you don't recognize. Overhead, two suns begin to set. One pale gold, the other a soft crimson. You sit there, watching the shadows stretch, listening to the hush of another world. You don't know the names of these stars, but they know you. You are a traveler, a listener, a dreamer of skies. And wherever you are, whatever planet, whatever sunset, you are home. Welcome back to Infinity Beyond, where we travel through space and time, not with engines, but with imagination. Tonight, we don't go far from home. In fact, we stay right here, on Earth. But we move forward, way forward. We ask, what will Earth be like in 1,000,000 years? 1,000,000,000? What is the future of our planet? Close your eyes. Let's begin. The next few thousand years. In the near future, Earth will still look familiar. Continents shift slowly, drifting a few centimeters each year. Cities rise and fall. Ice ages come and go. If humanity survives, our influence may grow, terraforming deserts, restoring forests, building cities under the oceans, or even on the moon. But if we disappear, Earth will quietly reclaim what we built. Within a few centuries, plants would overrun cities, wildlife would flourish, skyscrapers would crumble, satellites would fall, the planet would heal, slowly, naturally. Time softens everything. 100 million years from now, a new Earth. By 100 million years, the continents will have shifted dramatically. Africa may crash into Europe, forming new mountain ranges. The Atlantic Ocean might widen or close entirely. Volcanoes will redraw coastlines. New species will evolve, some strange, some familiar. The atmosphere may be thicker with carbon dioxide or thinner. Sea levels may rise or fall. Earth will still be alive, but in unfamiliar shapes. Humanity, if it still exists, may no longer resemble us. Perhaps digital consciousness, perhaps scattered across planets, or perhaps gone, leaving fossils buried deep beneath alien jungles. And Earth, she keeps turning. 1 billion years. The sun grows hotter. Here's where it gets serious. The sun, like all stars, is changing. Slowly, it grows brighter, about 10% every billion years. That may not sound like much, but for Earth, it's everything. In 1 billion years, increased sunlight will heat the surface dramatically. Oceans will begin to evaporate. Rainforests will collapse. Weather patterns will shift wildly. The water cycle may break. Clouds vanish. Deserts expand. Eventually, the oceans, our cradles of life, may boil away into space. It won't be sudden, but it will be relentless. This phase marks the beginning of the end for habitability. 3 to 4 billion years. Venusification. By this stage, Earth may resemble Venus. Surface temperatures rise above 400 degrees. The atmosphere becomes thick with steam and carbon dioxide. Any surviving life must be extreme, microbial, deep underground, or artificially sustained. Rocks melt. Tectonic activity slows. The magnetic field may weaken or vanish. From orbit, Earth might still look blue at first, but up close, it's a sweltering, cloud-wrapped furnace. Not dead, but very close. Billion years, the red giant sun. The sun, now near the end of its life, begins to swell. Hydrogen in its core is exhausted. It expands into a red giant, engulfing Mercury, Venus, and maybe Earth. If not swallowed, Earth will be scorched. Its surface, melted, reshaped by heat. Atmosphere, stripped away. Oceans, long gone. A ghost planet. All traces of life, all signs of civilization, are erased. What was once a blue-green world becomes a scorched cinder orbiting a dying star. But even that is not the final chapter. 7-8 billion years, Earth's remains. After its red giant phase, the sun sheds its outer layers, becoming a white dwarf, a tiny dense ember of a star. It no longer fuses atoms. It simply glows with leftover heat. Earth, if it remains in orbit, is a frozen husk. No atmosphere, no oceans, no tectonics, just silence. A memory in stone. Yet in this silence lies poetry. For over 10 billion years, Earth danced with the sun, gave rise to oceans, forests, thoughts, dreams, and then returned to stillness, a planet that lived. Far future, into the unknown. Beyond Earth, the universe continues. Perhaps life from Earth has spread, on Mars, Titan, orbiting distant stars. Perhaps the Voyager probes still drift, carrying golden records through the dark. Perhaps our thoughts, our art, our wonder, encoded in some digital archive, are rediscovered by minds we cannot imagine. Earth's surface may be gone, but its spirit may echo across the stars. Because Earth wasn't just a planet, it was a stage, a birthplace, a beginning. As you fall asleep. Tonight, picture yourself standing on a high ridge, watching Earth change. You see forests give way to sand, oceans shrink, skies turn strange colors, and above, the sun grows, flickering red. You are calm. You are timeless, because even as the world fades, you carry its memory. The laughter, the rivers, the sunsets, and you understand nothing lasts forever, but everything matters. Even the quiet story of a little blue planet circling a yellow star. Welcome once again to Infinity Beyond, where we explore the quiet mysteries that shape the cosmos. Tonight, we turn our attention not to the stars we see, but to something we can't see at all, something that surrounds us, moves through us, holds galaxies together, but remains invisible. This is the mystery of dark matter. What is dark matter? Let's begin with a simple fact. When astronomers look at galaxies, how they spin, how stars orbit, how clusters behave, they see something strange. There isn't enough visible matter to explain the movement. Stars orbit too fast. Galaxies hold together when they should fly apart. Something unseen must be providing the gravity. That something is what we call dark matter. It's not a planet, not a gas, not even a black hole. Dark matter doesn't emit light, absorb it, or reflect it. It's completely transparent. But we know it's there because of its gravitational pull. It's like watching leaves swirl in the wind. You can't see the wind, but you know it's real. How much dark matter is there? Dark matter isn't rare. It's dominant. In fact, only about 5% of the universe is made of normal matter. Everything we can see, touch, measure. The rest? Roughly 27% is dark matter. And a whopping 68% is something even more mysterious: dark energy. So when you look up at the night sky, realize this: everything you see, stars, planets, galaxies, is just a tiny fraction of what's really out there. The universe is like an iceberg. What we observe is only the tip. How do we know it's real? In the 1930s, astronomer Fritz Zwicky studied galaxy clusters and noticed they weren't behaving as expected. Decades later, Vera Rubin confirmed that individual galaxies rotated too fast for their visible mass. Something extra was holding them together. Today, we confirm dark matter in many ways. Gravitational lensing, where light from distant galaxies is bent by invisible mass. Cosmic microwave background. The afterglow of the Big Bang reveals patterns explained only by dark matter. Galaxy formation models, which don't work without it. The evidence is overwhelming, yet we still don't know what it is. What might it be made of? Dark matter might be composed of exotic particles that don't interact with light, only gravity. Some candidates include WIMPs, weakly interacting massive particles, axions, ultralight particles, sterile neutrinos, or even primordial black holes. Many experiments, like those in deep underground labs, are trying to detect dark matter particles. So far, we haven't caught one. Not directly, but the search continues. Some theorists even suggest that dark matter may not be particles at all, but a sign that our understanding of gravity needs to change. It's one of the biggest open questions in science. Why does it matter? Dark matter isn't just a curiosity, it's essential. Without it, galaxies wouldn't exist. Stars would drift apart. The universe would look nothing like it does. It's the scaffold upon which all structure is built. Imagine constructing a building. The steel frame is hidden behind walls, but it holds everything up. Dark matter is the cosmic frame, silent, invisible, but absolutely vital. What does it teach us? Dark matter reminds us of something humbling. We don't know everything, not even close. It teaches us that the universe is more mysterious than we imagined, that there are forces, fields, and forms of matter we've never seen, but which still shape everything. It teaches us to listen to the invisible, to trust what the cosmos whispers, even if we can't yet explain it. As you rest tonight, close your eyes. Imagine drifting above a galaxy, its spiral arms glowing with billions of stars. But around it, something more. An unseen halo, a dark skeleton, holding the stars in place. You float not through light, but through gravity, through the invisible sea that gives the universe its shape. And in that stillness, you realize, sometimes what we cannot see is what matters most. Dark matter is not emptiness. It is a presence, a quiet architect of everything. Welcome back to Infinity Beyond, your serene space to wonder, drift, and dream. Tonight, we face one of the most haunting questions in astronomy. Not about stars, or black holes, or dark matter, but about absence. The silence, the distance, the strange emptiness of the universe. Why, in a cosmos filled with billions of galaxies, trillions of stars, and countless planets, does it all feel so quiet? Tonight, we explore the beauty and the melancholy of cosmic loneliness. The scale of emptiness. When we look up at the night sky, it may seem full, stars twinkling, the Milky Way stretching overhead. But what we're really seeing is just a thin film of light, surrounded by vast, immeasurable dark. Between stars lie light years of empty space. Between galaxies, millions of light years. The closest star to our Sun, Proxima Centauri, is over 4 light years away. That's about 40 trillion kilometers. If you shrank the Sun to the size of a marble and placed it on a football field, the next closest star would be another marble over 6,000 kilometers away. The universe is not just big, it is mostly empty. The Fermi paradox. And that leads to a deeper question. If the universe is so vast, where is everyone? This is known as the Fermi paradox, named after physicist Enrico Fermi, who famously asked, "Where is everybody?" With billions of Earth-like planets in our galaxy alone, intelligent life seems probable. Yet we've seen no signs, no messages, no probes, no visits. Why? Are we early? Are we rare? Are we simply isolated? Possible answers and possible sorrows. Some scientists suggest that civilizations are short-lived, that intelligent life tends to destroy itself before spreading far. Others believe the universe is teeming with life, but separated by such immense distances that communication is nearly impossible. Still others suggest we're being watched, but purposefully ignored, a concept known as the zoo hypothesis. And then there are those who think we truly might be alone, that the conditions required for life are so specific, so improbable, that Earth may be the only place where the universe became conscious of itself. It's a chilling idea, but it also makes us precious. The anthropic perspective. There's another lens to consider, the anthropic principle. We find ourselves in a quiet part of the universe, because only in quiet places can life evolve. If Earth were near a supernova, or inside a galactic core, or in a star cluster filled with radiation, we wouldn't be here. Maybe silence isn't loneliness. Maybe it's protection. Loneliness among stars. And yet, the feeling remains. Even when we discover exoplanets, or send out radio waves, or launch golden records aboard Voyager, the response is silence. But silence can be beautiful. It gives us space to wonder, room to grow, time to reflect. Loneliness is not the same as emptiness. It can be full of longing, full of meaning. When we look at the stars, we're not just searching for others, we're searching for connection, for significance, for home. And sometimes that search leads us inward. The emotional universe. The universe is not cold. It is vast. It is not ignoring us. It is simply silent by nature. And in that silence, we project ourselves, our hopes, our fears, our curiosity. Maybe the silence is not proof of absence, but an invitation to listen closer. Maybe we were never meant to be answered. Maybe we are the ones who must speak first. And you close your eyes. Tonight, picture yourself floating between stars. There's no sound, no wind, no motion, only stillness, only space. You pass icy moons, golden clouds of gas, glowing galaxies suspended like fireflies in the dark. You feel small, but not lost, because even in this vastness, you exist. You are the rarest thing, a conscious mind in an unconscious sea. And in your thoughts, the universe becomes self-aware. Loneliness is not the absence of others. It is the presence of self in a universe that waits quietly to be known. Sleep well, stargazer.